This is a video for AQA Mechanics, Impulse and Momentum section 1.2, where we're introducing the idea of impulse. We've already met the idea of a force doing work when it moves a mass through some sort of distance d. So the work done by the force F multiplied by d gives us a change in the kinetic energy of the mass. So we can write an equation for that to say that the work done is the final kinetic energy minus the initial kinetic energy. But what we want to do now is to say, well, what if the force, we don't know how far it moves, but we do know that it acts for a period of time. Now, force multiplied by time gives us a quantity which is known as the impulse, and it's impulse which changes the momentum of the mass rather than the work done which changed the energy. So we can say that the impulse I is force multiplied by time, and that impulse is equal to the final momentum minus the initial momentum, which is the change in the momentum. Notice here we've got vector quantities. Impulse is a vector because force is a vector, and of course momentum, mass multiplied by velocity, and velocity is a vector. So we have vector quantities here. The units of impulse are usually done as the units of Newton's force, that is, multiplied by time seconds. So we get a Newton second. This is equivalent to the mass multiplied by velocity. Mass multiplied by velocity would be kilograms meters per second. But if you were to do some dimension analysis on that, you'd realize that these quantities have got the same dimensions, so these are equivalent units to each other. We can write an algebraic equation for this idea. If we have a force multiplied by its time to give the impulse, then we can say that the impulse final momentum minus initial momentum. So the impulse is force multiplied by time, and the change in the momentum mv minus mu. And it's this equation that we're now going to use to look at one or two examples of this in practice. So in our first example, we have a ball which is approaching a wall at 5 meters per second and then rebounds off the wall at 3 meters per second. So we want to work out the impulse exerted on the ball by the wall. Well, let's draw a diagram first of all, just to put all of that information into a picture. And because these are vector quantities, we need to define a positive direction. I'm going to take positive to be towards the wall. So I can now say that the impulse, which is I, is equal to the change in the momentum, so that will be mv minus mu. So m is 2, the final velocity v is negative 3, so we've got 2 multiplied by negative 3, and then minus 2 multiplied by the initial velocity 5. So in total then we get negative 16 Newton seconds. Or in other words, there's an impulse on the ball equal to 16 Newton seconds to the left or away from the wall. In the second example, we're going to have the same mass, this time moving at 5 meters per second, speeding up to 12 meters per second because the force is acting for a time of 4 seconds. So in a picture, we've got our before and after situation, and then we can indicate the impulse as being force multiplied by time. Again, we need a positive direction, so taking that to the right, we can now say that force multiplied by time, the impulse, is the change in momentum, mv minus mu, so that the force multiplied by 4 is equal to the mass 2 multiplied by 12, the final momentum that is, minus 2 multiplied by 5, the initial momentum. And that comes to be 14 Newton seconds. Therefore, to get F, we need to do the 14 divided by the time 4. F must be 14 over 4, which is 3.5. Of course, this is a force, so its units are newtons. And in the final example, then we have a question which asks us to find the impulse on a body of mass 3 kilograms when its speed changes from 5 meters per second in one direction to 4 meters per second in the opposite direction. So there we are with the diagram again, and also to indicate the positive direction. The impulse is equal to the change in momentum, so we can say that I is equal to mv minus mu. V is going to be negative in the direction that we've defined as our positive direction, so we get 3 multiplied by negative 4 minus 3 multiplied by 5, and that gives us a total of negative 27 Newton seconds. In other words, there is an impulse of 27 newtons in the opposite direction to that initial motion. Well, that brings us to the end of this short video on impulse, and in the next video we'll be considering the idea of conservation of momentum.